Pollution, waste, and debris is not confined just to Earth. In fact, we're starting to see this up in space. Now, as we launch more satellites and as we expel more second stage parts to rockets, we're starting to fill that space area with all kinds of debris. Now, according to NASA, we've got at least 500,000 pieces of debris flying at 17,000 miles an hour around the Earth. Now, some of these will fly slower, some will be faster, but then we also have millions of pieces that are the size of paint flakes. And so these things combined produce an enormous obstacle course for rockets that are now flying to the moon or further out, or even just when we're putting up new satellites. Now, this debris starts to exacerbate when you get satellite collisions or the remains of rocket boosters or other debris starts to fly into new satellites. And it just compounds the problem. With every collision, we might get 10,000 more pieces. Over time, some of the major incidents were, for example, like in the 1980s, a French rocket blew up and created a debris field that eventually collided with another French satellite a decade later. In 2007, China tested a defense system and fired a rocket to destroy an expired weather satellite. And this created 3,000 new objects that scattered throughout that layer in the orbit. In 2009, an expired Russian satellite collided with a commercial U.S. communications satellite, creating another 2,000 objects, in addition to damaging a perfectly good satellite. So as more junk fills our space, the probability of these collisions is just increasing. So this is leading a lot of people to start thinking about how we're going to manage all this, and do we have a centralized way in which we can operate all this and the traffic through this, kind of like an air traffic control center. So the main hazards that we have with these debris fields includes collisions with other satellites and increasing the field, collision with space habitats like our International Space Station, and now that commercial space flights are underway, it can create hazards for them as well. Collision with vehicles that are going to the moon, Mars, and anywhere else. And then even just the material that starts to fall back to Earth. If it's large enough, it can actually make it to the surface of the Earth, threatening human population on the ground. Just as we have recycling and a lot of business centered around garbage and waste in the United States and other parts of the world, companies are starting to take a look at how they can capitalize on managing space debris. Japan has a program where they're trying to consider launching electromagnetic tethers to slow the orbit of debris so that it eventually drops through the atmosphere and can burn up. Switzerland has its own program, Clean Space One, to capture old satellites, maybe to refurbish. This is before they actually fall back to Earth or before they collide with anything. Britain has a program, like a large sail, to push debris into lower orbit where it can slow down and fall into the atmosphere and burn up. And finally, the United States has its own programs that will blow a burst of air at satellites to introduce atmospheric drag and allow them to fall to lower orbits and eventually burn up in the atmosphere. These and many other systems are being conceived to help establish a way to capture, recycle, or just clear up some of that debris that's up there. In addition, ad hoc organizations are being created, for example, the Space Safety Coalition, to create best practices so that when satellites are coming near the end of their life cycle or their expiration date, that there is some kind of mechanism to bring them back to Earth or to allow them to be destroyed, but so that they don't create more debris. All of these initiatives require some kind of coordination between the different agencies, and there are numerous ones, as you see on the Space Safety Coalition site. So the Europeans have to be talking to the Japanese and Chinese and Indian countries, so that all of these organizations and countries can establish a protocol so that they can fly safely through these areas. Now, NASA and the European Space Agency have tracking mechanisms, and on more than one occasion, astronauts have had to go into a sequestered area, protected safety area in their capsules when satellites or debris comes within a few miles of their orbit. The safety zone is roughly a box that's 30 by 30 by 1 mile, so it's a pretty large box, but this allows plenty of margin for errors in estimating the orbits of this debris so that it doesn't come anywhere close to the space station. Nevertheless, when inspecting the solar panels and the panels of other satellites, scientists have noted that there are impacts from very tiny flakes of material that are pretty much impossible to track. Now, many satellites, when they're pushed up into an orbit, they follow a train of satellites, particularly in the polar orbit. And so each satellite, think of it as a different car on that train. They're all following each other roughly in tandem. And when some satellite has to cross that path, generally we can detect it about 3 years in advance so that you can plan for any kind of maneuver if you have to cross the path of these different trains. So when we're talking about space debris, there are all kinds of things that go into that material. It could be things that astronauts drop during a spacewalk. It could be material that drops off from satellites, just random bolts and things. It could be the remains of rocket bodies as they're moving up into space. All kinds of materials and things are flying off these objects as we're getting up into the space environment. And eventually, it's going to cause a debris field to form in those different orbits. Now, the Department of Defense tracks everything in the lower Earth orbit that's about the size of a grapefruit or bigger. That's about 300 kilometers from the surface of the Earth. There's also the geostationary orbit that is 36,000 kilometers away. And again, NASA and the Department of Defense are trying to track everything that's now 60 centimeters in size. Now, to shield the space station and our satellites, people are constantly working at new materials to help deflect some material that might be a centimeter in size. Larger than that, it's going to be pretty tough. But think of things that are going 7 kilometers per second. That's 17,000 miles an hour. That's a big challenge. And even the space shuttle, when it comes back to Earth, you'll see all the little nicks and dents in the windshield, and that's why they actually have 3 windshields.